It's not uncommon for organizations to have the same administrator password set for all their Windows servers and all their Windows desktops. So if you've got one password for a single desktop, then you've got the local admin password for all the other desktops and all the other servers. So looking to make sure that these accounts are rotated. They're part of our normal policy. Everyone has their end user password, has to change on a regular basis. But the privileged accounts, which typically far outweigh the end user accounts, are not usually managed in the same way. And when I say far outweigh, if you think about a typical infrastructure with, say, 1,000 employees, that's 1,000 laptops, 1,000 desktops. Each has a local admin account on it. There's the network to support those. There's the domains. There's the Exchange servers. There's the databases. There's the applications. Each and every single piece of infrastructure I've talked about there has a privileged account on it. So usually we see 2 to 3 times the number of privileged accounts in a company than we do end user accounts. And if you think about how much we focus on identity access management, it's surprising that privileged accounts doesn't get the same kind of focus or any kind of focus sometimes. So it's looking to protect those accounts and making sure they're rotated, but also controlling who can access them. By rotating the passwords, you take it away from the users, and you create a control point that says, well, if you want to gain access to this highly sensitive server, you need these credentials. These credentials are protected. Then what we can also look to do is start to monitor that access, which is very important for third parties. Not only monitoring what they're doing with these accounts, because we want to understand, we want to provide accountability around generic usage, but also controlling how they actually connect to the systems. So removing maybe direct network access to the target systems. If a user's machine has been compromised through malware, et cetera, and they have direct connectivity to a target system, or they know passwords off the top of their head, keystroke loggers might capture the password, or if they have a direct network connection to a database, then in theory there's the ability for malware maybe to piggyback on the back of that. So by controlling and proxying maybe the way that the users gain access to the systems, provides us with greater control to stop and break that cycle I talked about. And then really what's important is wrapped around all of this is real-time analytics, looking and trying to spot with these accounts that we know attackers use in pretty much every single data breach, looking to spot where these accounts are being used abnormally, are being used potentially by an insider up to no good, or potentially by an external user that gets compromised one of our inside accounts. Okay. So just to summarize those quickly, apologies, obviously I'm from a vendor, and I actually have got vendor pictures of our product, but it's because for a rare occasion, a vendor here saying this is a free of charge utility. So that's why I don't feel too guilty about putting this up. Okay, so this is a utility that we call Discovery and Audit, or DNA for short. And what it does is it basically does the first step that I talked about. It helps organizations understand the scope of the privilege account problem that they have by scanning, looking for privileged accounts, and coming back with a high-level report that says these are the number of privileged accounts you've got, these are the number of accounts that may be non-compliant. Simply what we're saying by non-compliance is the password isn't being changed regularly. These are the servers they've got access to. This is when the password was last changed. These are the services, the scripts, the scheduled tasks, etc., that this account is looking to run. And linking back to the pass the hash thing that I mentioned, also help you map out any potential vulnerability. So this map here that comes with the Discovery utility says, well, if one server's breached, and you can click on that server as part of the map, this is where an attacker could move to using pass the hash techniques. And then you know what? You can click to one of the other servers and show where they can move there and show how an attacker, in theory, could move around your organization using a very simple technique, as I say, using utilities that are free on the internet. We're also doing a similar thing for SSH keys as well. So the discovery piece is important because it gives us that starting position. And then it's looking to actually put those preventative measures in. So rotating privileged accounts, putting them in a secure repository. We talked about the attack before with a standard password to a credential repository, putting true protection around them, encrypting the passwords, and actually putting access controls. The problem with things like KeyPass, et cetera, is that once you're in, you've got access to all the passwords, and there's no audit.